Right, I'm just going live for a bit. The audio sucks, I know, I'm sorry about that, but I haven't got a mic. I haven't got a mic preamp sorted out yet because no, these are the gears. I got the gears for what? Now I blew them up. These are the sun gears. This one's an adapter for a NEMA motor. Well, the NEMA adapter thing is much too big now, but yeah, don't matter. I don't have a NEMA motor anyway, so I'm just gonna use a shaft, and I've just got to get the support material off here. Which is a bit of a pain. It's not too bad though. I'm actually recycling it to make some glue, so I'll melt it down in acetone in here. So I'm trying not to waste any plastic really. I'll just make some glue out of it. I've got all these different colours. I've got green, blue, red, yellow, you know, just about every colour you can think of really. And I've got pink now as well. This is pink. I got this because it was on offer. It was cheaper. It was about half the normal price. 1 kilogram roll normally cost you about 13-14 quid. Well, this particular brand anyway. And this was only 6 quid. So well, I'm not going to complain. Free shipping as well. So I'm just going to clean up the gears a bit. Get this support material off. I thought I'd do it live because I can't hold my phone while I'm doing this. I can't, you know, just can't do it. So it's not really about the dialogue, it's just about the process really. I'll show you the planet gears in a minute. This is a sun gear. I've got 2 sun gears here. I've printed 2 out. It actually took about, what, 8 hours to print these 2. They're actually pretty big as well. I'll just give you the dimensions on it. Right, the hex is actually 14mm hex. The actual... This is too long, by the way, this piece. I've edited it in SketchUp to make it shorter because it's just ridiculously too long. It's because I've scaled everything up, you see. Well, this is 98mm long, that's way too long. I've actually took 15mm off. But I could cut this off, I suppose, because this is solid anyway, so there's not, I could easily cut a piece off here. But the gears themselves measure 22mm outside diameter. It's fallen off now. 22.03mm outside diameter for these gears. And oh yeah, that's a point. How round are they? 21.95, 22, 22.17, 22.28, 22.33, 22.18. That's pretty round. 21.97. It's actually a bit under there. Yeah, it's good enough. It's certainly good enough. I mean, there's some slight tolerance issues on there. I need to tweak my calibration a bit more, but there's an issue with the printer actually. There's a problem with it. Everything I print on the printer, I've been in touch with some support guys online and they can't seem to figure it out either, what's going on, because the bed, the mechanical structure is dead square. Now let me just draw this square. Right, now this is the printer bed, right? So it's a rough drawing. Right, so we've got this square, right? Now the problem I'm having is that everything that's printed on the left side of the bed is actually a little bit shorter than stuff I print on the right side of the bed, which doesn't make any sense, because no matter, even if the bed was cockeyed at an angle, when I'm printing a square, it should still be a square, even if the square isn't square with the bed. You see what I'm getting at? So basically I've got 1mm more on the left side of the printer bed than I have on the right. So anyway, if I print everything in the middle, if I print a circle in the middle, then technically what that means is that this side of the object might be slightly longer this way than the object on this side. So my round things are never coming out perfectly round, but good enough anyway. It's just very, very confusing. I'm trying to figure this out. I mean, no one seems to know what the problem is. I don't know what the setting is. I don't know what settings in the firmware I need to adjust to compensate that it's skew or something. I think I've got a skewing problem. Everything's skewed, and it's nothing mechanical because I've set that all up. There must be something in the printer firmware that somebody set previously, which they'd put in possibly erroneously by a mistake to try to correct for something else, and it messed it up. So I don't know. Apart from flashing the firmware, I'm just getting support material residues out of here at the moment. Oh damn it! I blew the damn stuff everywhere. I don't want to do that. I'm trying to collect it on this piece of paper. Right, so I'm just don't want the support material going all over. I have to vacuum up then, you see. My robot can't vacuum up. My robot vacuum has a hard time picking up plastic, because what happens is the thin strands of plastic gets wedged into the fibres of the carpet, and it just can't pick them up because they're just kind of threaded into the carpet. So I've got to manually go around with bloody tweezers picking the damn stuff up, which is really annoying. That's the trouble. I've got these nylon rubber backed mats. They work very well, but the plastic stuff seems to stick to them quite a lot. So yeah. Alright, so now I've got my gear teeth cleaned out. I've got this cleaned up and got this support material off. What I do is I soak them in acetone, in atmosphere of acetone, for about an hour, and it what's the word? I think they call it annealing. I think that's what they call it. Right, these are my planet gears. Right, these are the planet gears I did earlier. 5 of them, and they're all numbered actually. The ones that geared down for Watt design. Yeah, I've had these in the acetone gas atmosphere in this container, and it's made them really solid now. Right, so I've got acetone in this container, right, so basically I just take the lid off. I've got a tissue on which I soak with acetone silver. Oh god, but it stinks, it's really strong in there. I nearly knocked myself out then. I wasn't sure if the gas was still in there. I probably need a bit more actually, so I'll soak this tissue and put the lid on, seal it up, and I'm going to leave that now for about yeah, it's true what they say about this acetone. It's actually a heavy gas, so it sinks to the bottom of the container. It's heavy, it stays in there, so I'm going to leave these in the container now for about an hour. I'm going to set my timer. And that'll anneal everything and make it really solid. Yeah, I sorted that problem out, Danny. I know the solution for that. Right, so I just put this other stuff in this thing here. Right, so here we go. Okay, that's that in there. Oops. Actually, no, I thought that was a solution, but no, it's not a good idea. I know the answer. Are you watching? Danny, are you watching my live stream? Right, well, look, I'll explain it. Now, my right motor, right, on the printer is wired closer to the circuit board than the motor on the left. Now, because of that, it gets more current, right? It gets a much bigger pulse because it's so close to the Arduino board, the driver, the MOSFETs. Because of that, that particular motor will accelerate faster than the one on the left, which is at the end of a long wire. And because of that, the sudden pulse of power that comes from the Arduino MOSFET driver circuit will kick that first motor near the Arduino much harder than it kicks the other motor, which is on the far left. The way to solve that is simply to drop the acceleration, and then both motors will stay in step. I've only had to correct my Z-axis motors by one step, and that's usually after the motors have been powered down. And if the step is actually on the edge of another step, sometimes it might just, when you first power it up, when you first power the printer up the next day, the motors will re-lock. The power energizes the motors and they automatically lock again. Well, sometimes the motor will lock on the step next to the other step, instead of the first step, so that it can just throw them out by a step. But that's nothing really. I just keep my screws lined up and I know where I am now, so it works anyway. So what you do, let me just get rid of this a minute. Where's my thingy? Oh, I don't think I can look at my firmware because I haven't got the printer plugged in. Oh, I can plug it in. Just a minute. Hang on a minute. Where's my wire gone? Where the fucking wire is? Oh, down there. Right, found it. Hang on. Oh, I've got the fucking camera. Just a minute. I have to swap camera. I have to swap my USBs over. Just a minute. I'll just go to an image a minute. Just a sec. These flipping wires, I hate them. Right. Right, I have to swap my right, let me just go to, I'll just bring up Repetier host a minute. So am I connected to the, oh bugger it, I aren't. I'll disconnect a minute. I have to reinitialize the flipping thing. Stop local server. Server. Start local server. Connect. Right, now I'll go to the firmware. Right, the firmware settings. The acceleration is on Z-axis acceleration. There we go. Right, let me put the screen on a minute. Right, okay, you want the Z-axis acceleration, that's this one here, right? Okay. And you just, mine was set at 100, right? This one here was set at 100 before, and you just set it to 30 and it works great. Right, so set Z-axis acceleration to 30,000 mm-s cat2, whatever that is. So this is the one that wants changing, basically that one. Yeah, so if that's just set lower, it doesn't make any difference to the speed of the print. It just stops the jarring you get on the steppers, you know, so they don't go like that, like a whip, and often that's when they get out of step, and they start slipping steps every time it does that. But because it's running slower at 30, they don't get out of step, because they're driven, they have a soft start, you know, they have a softer start. So the motor that takes all the current, the first motor on the right, nearest the power supply, the board of the driver, that doesn't get all the juice or the power anymore, so both motors get an equal chance of moving, you know, basically. So anyway, that's what I did, and it works. So I probably need to send this video to Z. Did you say it was Z that had this problem? So I'm probably going to email him actually. Oh, who was it then? Who had the problem? I thought you said Z had it. You pause. Oh, right. Oh, you're talking about the Z-axis. Oh, right. Okay. I thought you meant the zero had the problem as well. All right. I've got you now. Yeah. Well, I had a support thing on that. Yeah. Yeah, I've got you. Yeah, alright then. Well, anyway, that's what I did to sort mine out. I'm going to clean this printer bed up because I've got to get another printer print thing started. Right, I'm just trying to get this printer ready for another print job. So I've got another. I've got to start doing the outside gears. I've got to do the. Well, let me just show you anyway. Right, the ones that I've done, the ones that I've printed is. Oh damn it! Wrong one. I've opened two of these now. Flipping heck! What am I doing? I can't aim my mouse. I'm getting old or something. Right. So I've done these planet gears. Right. Have I still got the screen on? Yeah. Right. So I've got the planet gears printed, right? And I've got the optional. I've got this. I've got two of them open now. What the heck? I've got the sun gear. Where the hell's that gone? Oh, it's over here. It's in the wrong place actually. It wants to be. It's just stupid. It's supposed to be. Oops. Hang on. It's supposed to be in there. Right. It's not lined up properly right now. Get it right there. That'll do. So that sun gear goes in the middle like that, right? And then we get the print. Then we get the. Hang on a minute. I've got two windows open. I don't know what I'm doing. Right. And then there's the rings that go on. Right. So there's ring. God, that's not even set up properly. Hang on a minute. The ring gear goes on. That's one ring gear. Actually, that's in the wrong place as well. I think that's ring gear number 1. So that should be. Why didn't this guy line them up so they're in the right position? Right. So ring gear number 1 goes on like that. Ring gear number 2. This is probably not lined up either. No, it's not. Right, so ring gear. Oh, what's it doing over there? Oh, yeah. So ring gear number 2. Right. Some of these are all lined up properly, but not all of them. So ring gear number 2 goes on. And so on, right? There's actually 3 gears set on this one. I'm using a 3 ring gear set, so actually it wants to be in the middle there. That wants to be a bit more. Something like that. So anyway, that's basically this compound planet gearbox, and they're very good actually. They've got a lot of torque. That's not lined up right. This other one's not. Right. So yeah, that's basically. I've got to put these together soon. Right. So I've got to print these out. Right. I've got to print that one, and the number 3 as well. Well, it's just the same as these really, but actually it's the same as number 1 because the ring gear 2. And ring gear 1 are different because so if I take that ring out in a minute, remove it, you'll notice that the gear size is slightly different. These gears on these planet gears are slightly bigger diameter than the ones in the middle, Yeah, so anyway, that gives the differential speed, the gear reduction, whatever. Yeah, so anyway, enough of me waffling. Sorry about the audio, it sucks, I know, but I haven't got around to making the circuit board for the new mic preamp I'm going to build. I've just been too busy with other things. I mean, making videos is not my priority. I've just got other things I want to be doing. I don't want to spend 3 days editing videos when I could be doing something more interesting, you know. Because let's face it, I mean, anything you put on YouTube these days, it's all volatile and it might not be there in 5 years' time anyway. So, but certain things that you make will still be around. I mean, I built things back in the 80s which I've still got and still work. So I think that's more practical in my view. It's something that. I mean, I've got this little gearbox here. Let me just go back to the camera again. I've got this little gearbox that off Gears for What, and it works really well. Yeah, this is a 4-planet gearbox. It works really well. I'm just turning with my fingers right now. So as I turn this middle one, the middle ring turns around. What I like about it is because it's the rings on the outside, it holds pressure on the gears, so the gears are always nice and snug and tight, and there's a bit of springiness in it, and the guy that designed it did a good job of it actually. There's that springiness that keeps the gears nice and snug, so you don't get flapping gears that are loose. But sometimes I notice that these outside rings that hold the gears in place stretch a bit, or the gears wearing, and it gets a bit loose. I think it's mainly because mostly because the ABS on the rings stretches a bit and the gears compress a bit or wear in a bit, and so sometimes the rings get loose. So I had to print some slightly oversized and some slightly undersized so I could compensate for that. Right, so yeah, I don't know what's going on there, but Hacksaw's back. So anyway, not much else to talk about right now. I want to get this print job started. I'm just getting the tail prepped a bit. Right, so at the moment I got to get the other one loaded now, so where are we? Go back to desktop a minute. I've got to end the stream in a minute anyway, because let's go to, I think that's the right one. I'm in the wrong, hang on, where am I? That's the wrong folder. I want to be in this one. That's the one I want to be in. So I want ring 1. I can't remember. I don't know how long this is going to take. I need to home everything first as well. Actually, I'll home everything. Right, so I want to get that one done. So if I put the camera back on, well, where's my? I don't know if you can see the printer. My Z-axis, I've got new brackets on there now, so my Z-axis is much better now. It's much more stable. Right, I printed all new brackets for the printer as well, so yeah. Alright, I think the print job started. Yep, okay, I can just leave that now. So I'm going to unplug this. I'm just going to close my repetier thing, because this gear is going to take quite a while. I'm just going to plug the printer into the power supply. Oh, yeah.